Hi everyone, how are you today? Today we're going to talk about rate of change. So it is the same as real life optimization. It's a little bit difficult. So what I want you to do is to focus on other topics first before coming back to these two topics, which are the more difficult one. Okay? So what this chapter is going to do is that it's going to use one rule. The rule that you have learned is called chain rule. Okay, then make use of chain rule to solve some real life application problem also. Okay, so let's look at this. Okay, what is rate of change? So you have something like this one, rate of change of something like area means how fast the area is changing. Okay, volume, how fast it is changing. So when you say how fast, okay, or how slow, then it means what? dt, okay, with respect to time, right? How fast and how slow. Okay, and it can be like length, how long this one is increasing. Okay, maybe you're talking about some moving objects or some expanding things like balloon. It's expanding at the rate of what? Okay, the volume is expanding, right? Okay, then distance, dx dt, say. Okay, so there are a few angle d theta dt. So whenever you say rate of change of an object, that thing, that quantity is on top, and below should be dt because it's a change with respect to time. All right, so let's look at one example here. So if you want to take more time to read the question, just pause the video and read it yourself. Okay, right. So now it's talking about a scenario where water is pumped into a spherical balloon. Means that the balloon is a sphere shape. It's not like an ellipsoid. Okay. Then the radius of the balloon is expanding at the rate of 5 cm per minute. Okay. So the radius of the balloon. So it's a circle. It's a sphere. Okay. Then the radius is expanding at the rate of this one. So means this one is what? dr dt. So the question gives you dr dt. Okay. Then find the rate of change of its volume. So rate of change of its volume, this one means what? dv dt. Okay, change of volume, of course, with respect to time. Okay, when the radius is 5 cm. So when r is equal to 5 cm. Okay, before I go on to show you the answers over here, I will just like do this question based on what is given. Okay, so I want you to know how one should approach this question before you go on and like list down a nice answer that. Okay, so now look at this one. These three things are the things that you have. Okay, these two in particular, you have this one and this one given. Okay, and you want to find this one. Okay, first is that the central idea of this whole thing makes use of what? Volume. Okay, volume of a sphere. Okay. What is the volume of a sphere? Volume of a sphere is equals to 4 over 3 pi r cube. Okay, so this is volume. Okay, if you have this one, can you differentiate? Can you differentiate? Yes, you can differentiate with respect to what variable? There's only one variable here, right, which is r. So you can know dv dr. Okay. You can know dv dr. Okay, you differentiate, it's equals to 4 pi r squared. Okay, so now let's say I have this one, okay, this 2, and this 3. Can you combine them in one equal sign using chain rule? You can write. What is the thing that you can write? You can write dv dt is equals to dv dr times dr dt. Okay, so now what do you want to find? You want to find dv dt. You want to find this one. Okay, do you have this one? dv dr. Okay, I look at this one. dv dr, I know is 4 pi r squared. Do I know r? Yes, I know r is 5, so I can substitute here. Okay, so it's 5. Okay, 4 pi times 5 squared. Okay, do you know dr dt? dr dt is given in the question. So you know this one, you know this one, so you found this one. Okay, so the main important thing in this whole topic is that you have to look at what is given, use the underlying formula for volume, for length, for area, surface area, whatever. So you have to make sure this one has one variable so that you can differentiate, and from this form a chain rule formula. Okay, then if you are able to write down this formula, you always be able to finish the whole question, because it's either given this one, this one, this one, this one, or given this one, find another one. Okay, so now I've done my explanation, so I can go on to talk about the answers, right? Okay, so let's see. Okay, let V and R be the volume and radius of the spherical balloon respectively. So you have to define what is V, what is R, because it's not stating in the question. Okay, it doesn't say, oh, what is V. If the question says V is volume already, then you don't have to define. Okay, it's a better practice that you define all the things, or else your examiners doesn't know what is X, what's Y, and what's your V and what's your R. Okay, so V and R is here. Alright, so V is equal to 403 pi R cubed, like what I said. Then what do? Chain rule formula. This one is based on the things that I have. Okay, dV dt is given. It's dV dt is the thing that you want to find. So this one, volume, change of its volume. So this is dV dt. Okay, and here this 5 per minute. This is dR dt. You have dV dt, you have dR dt. You want to find. Okay, you form a formula. You see here, you kind of think of it, dV dt and dR dt. So in order for it to appear in somewhere, you have to kind of cancel off the dr, and the top has to be the same. Okay, so you can kind of think of this as like cancellation, although this is one thing and this is one thing. Okay, cancel off, kind of. Okay, it's not the real one. Okay, because in theory, math doesn't have this one cancel because this is not division. This is one thing. Okay, but it's okay for you to think of that way, think of it in that way, so that it's easier for you to approach the question. Okay, as long as you get this one, everything is easy, because this is just 4 pi r squared. You differentiate this with respect to r, then multiply by dr dt. Same thing here. Okay, what you need to do next is just to substitute everything in. Substitute everything in. When r is equal to 5, dV dt is equal to 4 pi r squared. Then this 5 comes from this 5 cm per minute. So answer will be 500 pi. Okay, 500 pi. This one I haven't given you any unit, so this one should be cm cube per minute. Okay, hence the volume. Volume means cm cube, right? Okay, then at a rate of what? So each per second, per minute depends on the question. Okay, so 500 pi cm cube per minute. Okay, if the question didn't say anything, then better leave the pi here. If the question say let pi to be equal to 3.142, something like that. Okay, then this one should be just changing to the decimal places. Okay, so that depends on the question itself. All right. Okay, so I guess roughly you know how to do it already. Okay, the difficulty is here. So if you can, for the following questions, what you do, you try to come up with this thing, and then you shall continue. Right? Okay, so now a square is expanding. So square is expanding in such a way that its edge is changing at a rate of 3 cm per second. When its edge is 15 cm long, find the rate of change of its area. Okay, so if you can, please write down all the information and try yourself. And now you are looking for change of its area. So area is A. So you have to figure out what's the formula for A for this square, which is very simple, L square. Okay, so try yourself, then I'll reveal the answer. Okay, right. So now let A and L be the area of and the edge of the square respectively. Okay, then A is equal to L squared. This one you know already. dA dL is equal to dA dt, because this is what you want to find. Okay, change of its area, the rate. So this one, this change is dA dt. You can find this. So dA dt on the left hand side. Then making use of chain rule, dA dl, dl dt. Okay, so this one and this one cancel off. Okay, the rule cancel. Okay, so cancel off. So you kind of have this two. dl dt is it given? Check the question here. H is changing at the rate of 3 cm per second. So this one is given. Okay, how about this? Is this given? dA dl. dA dl will never be given, but you know the formula. You know the formula, you can differentiate because there's only one variable. After you differentiate, it gives you 2L. Do you know what's L? Yes, you know the L because when its H is 15 cm long, then you substitute 15. Then answer. So you substitute these two into here and you get the answer here, which is 90. So the area is increasing at the rate of 90 cm square per second. So cm and also second. Okay. Any difficulty? It should be quite alright, right? Okay. So this one again, it's like there are a lot of possibility. So it could be having different scenario for different types of questions. So I think it's because different times you are going to use different methods. That's why you might be a bit not too sure what to do. Okay. Other than that, it should be quite okay. All right. Next, a tank is of in the form of an inverted cone having an altitude of 15 cm and a base of radius 5. Water is flowing into the tank at a rate of 2 cm cubed per second. When the water is 4 cm deep, find the rate of the height of the water level and the rate of change of the area of the water level. So pause the video and try this one yourself. This one is slightly more difficult than previous one. Because why? Because inverted cone. Cone, the volume is what? Having two variables. One is the height, one is the radius. You have to make it to be having one variable only in order for you to solve it. Okay, so try yourself. Alright, so let's look at this. So the rate of height of the water level. So R and H are the things, radius and height. So RH is 515. ROH is 5 over 15. Do you know how do you get that? First of all, inverted cone means like somewhere like this one, right? Okay. Right? Okay. Then this one is R, correct? This is R. And this one is H. Okay, right here. Okay. Then you see that this is a triangle and it's a right triangle. Yes. Okay, so now let's say the water is like up to this height. So it's somewhere here until here. Okay, water is until here. So do you see another right triangle here? Yes. So it's this triangle and this triangle, they are similar triangle. Similar triangle, what can you do? So you can say R over H is equal to 5 over 15. What's 5 over 15? 515 is the original data for this one. So this R is 5 and this H is 15. The original cone, okay, that is given is 5 and 15. Okay, now it's like changing, right? The R and H is changing because the water is like flowing into the water, right? Okay, is it flowing into it? Yes, flowing into the tank. So flowing inside. So it's raising. So that R and H is changing. Okay, it changed from here to here. But no matter how it changed, it's still a similar triangle. So if it's a similar triangle, you may use this ratio to find the relationship between R and H. Okay, so you have this one. So I would write R is equal to H over 3. Then what do I need to do next? I need to find the rate of height of the water level means what? This one is dH dt. This is what I want. Okay. Then now this whole thing here flowing into water flowing into. So this one is what? This one is given here. So this is dv dt. You have this one, you have this one. Can you join them together? Yes, you can. What is this? dv dt is equal to dv dh and dh dt. Okay? So now I write down. So dv dt is 2 cm cube per second. So this one is a known information I write down. And volume of the water is V equals to 1/3 pi r square h. So now let me ask you this. You have two variables, right? Okay, one is r, one is h. Okay, then now dv dt, dh dt. You want everything here to be differentiated in terms of h or in terms of r. Think about it. Okay, you want to form a chain rule formula. Okay, so this one has to combine and put together with another term to form a chain rule equation. That equation, do you need this one to contain r only or h only? That depends on you, on how you want to substitute here. You want to represent h in terms of r or r in terms of h. Okay? Okay, good. You need to change everything here to h because this one here is going to be what? V. V is 1/3 pi r square h. And what's our chain rule formula? Can you tell me what's the chain rule formula? Chain rule formula, dv dt. We know dh dt. So here should be dv dh times dh dt. That's why we need dv dh. If we need dv dh, means that here cannot have r. Cannot have r. That's why we go on to differentiate with respect to h later on. Okay. So now what we are trying to do here is to eliminate the r. How do we eliminate the r? We want to get rid of r. So we write r in terms of h. R in terms of h. Okay. Then put it in here. Okay. R is equal to h/3. We put h/3 here, square it, multiply by h. So that will give us 27 pi over 27. Then h to the power 3. Yeah. Okay. So that's fine. So this is the chain rule formula, the one that I wrote just now. Okay. Then dv dt is equal to pi over 9 h squared dh dt. What information is given? H is what? H is 4 cm deep. dh dt is the thing that you want to find. Okay, is the thing that you want to find. Okay, and what's dv dt? dv dt is water flowing into it. So this is dv dt 2 cm cube per second. So we substitute in everything, then we can get this one right. So is it number? Then you have this one. Okay, so this one you move it over. Okay, so dh dt is just 9 over 8 pi cm per second. Okay, right? No, not a difficult one, right? Okay, it's kind of easier. Right? Okay, if you have anything, just pause the video and go back and just study this one again. Okay, let's move on to the next subpart. So the rate of change of the area of the water level. So rate of change of the area, dA, dt. Okay, dA dt. So again, these two are the things that we have found just now. So A is equal to pi r squared. Okay, area of the water level. Area of the water level. So water is like a circular cone. So it's like here, area. Okay, I want to know what height and what radius, right? Okay, A is pi r squared as usual. Then can you allow it to have r? You can't. You can't. So you change it to r equals to h/3. Then square is h squared over 9. So it's pi h squared over 81. So now you have A. You can differentiate A with respect to h. Okay, and you have this one dv dt. Then what do? You want to find dA dt. Okay, so what you have here is that dA dt is equal to dA dh. You can differentiate this. and dh dt, which is what? dh dt is given just now. We found it. Okay, we found this. Okay, then you see this information. Is it useful now? It's not useful anymore. This one is used in part A, not in part B. Part B, we make use of the answer in part A, which is this one. Okay, so this one should be placed here, and this one should be differentiated, put it here, and substitute H. What is H? H is how deep. Deep is 4 cm deep. Okay, so we have this. Alright, so you got this one, and H should be 4, and this one is given here. Eventually we get answer 109 cm squared per second. Hi, welcome back. So now we shall continue on more examples. A wire is bent to form a circle. So you have a wire is a long one, then you want to bend into a circle. So the circumference of a circle, P, changes at a rate of 0.4 cm per second when the circle is heated. Find the rate of change of the radius of the circle. Not very difficult. So given what? So P, because it's defined here already, so I don't have to define what is P again. So I know that dP dt is 0.4. And P is what? P is 2 pi r, because what? Circumference. Circumference of a circle is 2 pi r. Area of the circle is pi r squared. So what I can do is that I use this field information. I know P is a function of r, so I know dP dr. I have dP dr, I have dP dt. How do I find the other one? It should be dr dt. So now this dr dt, this dr dt is the thing we want to find. Rate of change of the radius, which is dr dt. Okay, so what we do? We substitute the information here, and we find this one. Okay, dP dt is equal to 2 pi dr dt, and then dP dt is 0.4, 2 pi is just 2 pi, no information needed. Hence, dr dt, you just move the 2 pi over, so it's 1/5 pi cm per second. Okay, no problem, 1/5, right? You may also use 0.2 if you want. Okay, so this is easy. Okay, let's move on to the next one. Water is poured into a cylindrical container with a radius of 5 cm at 20 cm cube per second. Find the rate of change of water level. So cylinder, you need to know all the formulas for volume, surface, area, and also area and so on. Okay, those things. So given that dV dt is equal to 20, so this is the change of the volume, right? Okay, change of volume, the water pour in at that rate. So it's dV dt is equal to 20, and R is 5. So V is also having two variables, pi r squared h. Pi r squared is a circle. You have to multiply by its height, then it becomes the volume of the cylinder. Okay, so now you know dV dt, and here you should know dV d what? dV, don't know, dV dr or dV dh. So now you have to figure out, okay, pi 5 squared. Why is it 5 squared? Does the radius change for the cylinder? No, it doesn't change, because no matter how many seconds you pour in water, the radius of that cylinder is still stick to 5. So this is a fixed value. It's different from a circular cone, right? If you have a circular cone, you see, and a cylinder, let's see. Okay, so bad drawing, but I think you can understand this. If you pour in water here, okay, and it reaches this level, I say h, okay, does the radius change? No. Okay, if you pour in water into here, then the level is here, this is h, then, and you point again, so this is h prime. Does the r differ? Yes, it differs. I mean, does the h differ? H differ and r differ. R is the radius. Radius change. Okay, radius change. This is small, this is big. Okay, this is the same as h prime. The radius is the same. That's why you don't have to use similar triangles in this case, this is very simple. You directly substitute r. Okay, no problem with this. Okay, I'll just get this off. Okay, so pi 5 square h, then is 25 pi h. Then now what do you have? You only have a function with one variable. Easy. So dv dt is equal to dv dh dt. So dv dt is equal to 20. Answer. 20 is equal to 25 pi dh dt, and you want to find dh dt. So you found it here already. Okay. So in case you're wondering what is this, you haven't done your homework. So this is dv dt is equal to dv dh times dh dt. This is the equation that you should formulate. You formulate this, substitute everything, differentiate, and substitute. Get the answer. Okay, it's this one. Okay, no problem. Great. So the formula is given there. So I just didn't pop it out just now. Okay, last one. So when a stone is dropped into a pond, a circular water ripple. So drop in the stone, then you have a circular ripple, right? Okay, like the wave shape. Okay, so it's formed. So the area of circular water ripple expands at the rate of 3 pi cm squared per second. When the radius is 2 cm, find the rate of change of the radius of the water ripple. So now, dA dt is 3 pi, this is given. Then A is pi r squared, because when you throw the stone, it gives you the circle shape of the water ripple. So dA dt is equals to dA dr, because this one only have one variable. You know the area is in terms of r, then dA dr has to be included. Okay, and dr dt. Okay, of course. So now you want to find dr dt, right? You want to find the rate of change of the radius. So you have to know these two. Okay, dA dt is given, dA dr is in terms of r. So you just need to know r is 2 cm, and you're done. Okay, so you just substitute everything inside. So the formula I substitute in, and then when dA dt is equal to 3 pi, r is 2, then 3 pi is equal to 2 pi times 2 pi times 2, then dr dt. So you can find dr dt now. Dr dt is just 3 over 4 cm per second. Okay, so I hope you are okay with this chapter and also this topic. Okay, this topic is a little bit more difficult. More scenarios is coming out. If you see more examples, then try to do as many as possible if you want to score an A. Okay, I'll see you in the next class. See you, bye.